Hey guys, welcome back. It's Mr. Haberek with yet another Algebra 2A video note lesson for you. Today we're going to talk about proportional reasoning. The reason we're going to talk proportions is because it's going to come up quite a bit in Chapter 2 when we're talking about lines. One of the things we talk about a lot is slope, and slope is rise over run. It's the change in y compared to the change in x. And that is basically a proportion, or it's a fraction, and all fractions really are proportions. And so we have to learn how to work with proportions. One of the classic proportion type problems involves this guy right here, cross products. With cross products, basically this is the general rule. If A over B equals C over D, this is the key. You have to have that equal symbol. Then AD equals BC. Basically, I can multiply the numerator times the denominator of each fraction, and I get these equivalent products. And that's going to make it a whole lot easier to find a missing value. So basically, I'm going to do this, cross products. In this example here, we have 5/48 equals 12.5 over y. So I get 5y equals 48 times 12.5. That is 5y equals 600. Divide by 5 and you get y equals 120. If we go down a bit here and we'll look at questions 1, 2, and 3, we can see the process in general. We have 326 equals n 78. So 26 times n goes here. 3 times 78 goes here. 3 times 78 is 324. Oh, I'm sorry, 234. Misspoke. Divided by 26 gives us an n value of 9. Number 2, 9 over x equals 4.5 over 9. All right, multiply 4.5x. So I'm doing this cross multiply. That's 9 times 9. 9 times 9 is 81. I'm going to divide by 4.5 to get x by itself. And guess what? That's going to be, I believe, 2. If I'm doing this math in my head right, it is 2. Yeah. So x equals 2. Here I have 4/17 equals 32 over t. So I'm going to do my cross products. I'm going to say 4t equals 17 times 32. So that means that 4t, 17 times 32, gives us 544. I'm going to divide by 4, and I get that t equals 136. Now, bear with me a minute here. If you've got an expression inside your proportion, you're going to solve that the exact same way. What do I mean by that? Well, I'm going to write out a problem for you up here as an additional example so you know what I'm talking about, because you are going to see these in your work tonight. Let's say I've got something like this. 5/8 equals f minus 1 over 56. This is a problem from the note packet that we're really not looking at right now. How do I do this? Well, I'm still going to do cross products. It's going to be 8 times f minus 1, 5 times 56. So 8 times f minus 1, 5 times 56, that's 280. So maybe I could do what we did in the last lesson and just divide 280 by 8. Yeah, I'm going to divide by 8, and that's going to give me with f minus 1 equals 35. I'm going to add 1, f equals 36. So that's one way to do it. You could also distribute. So I could do 8f minus 8 equals 288. That'll give me 8F equals, I'm sorry, 280. Add 8, you get 288. And then divide, and you would still get F equals 36. So if you have an expression instead of just a variable, you're going to have to work it out that way. Now if you look to the left here, one of our classic proportion problems, and there's a couple we're going to work at in this section, but right now one of the classics is this guy right here. Percent over 100 equals part over whole. You can think about it this way. Percent is part of whole. So they're going to give you some problems. And most of those problems, they're going to give you a percent, and they're probably going to give you the whole value, and you're going to have to find the part. But occasionally they're going to give you the part, and you're going to have to find the whole, or they might give you the part and the whole, and you're going to have to find the percent. No matter what, they're going to give you 2 out of these 3 variables. Notice 100 is always going to be there. So you're going to give you 3 numbers, 2 of those 3 numbers, and you've got to find the third. Like this example here. 35.5% of 4,800. Notice we say of 4,800, that means I've got the whole. So 35.5 out of 100 equals x out of 48. We're going to cross product, divide, and you get x equals 1704. If you look down here at question number 4, find 42% of 300. 42 out of 100 equals x out of 300. You're going to do some cross products here. We're basically going to divide by 100. And that is going to give me, let's see, 42 times 300 divided by 100. 126. 15% of 680. Well, percent always hangs out with 100. So look it, I'm going to put 15 right up here above my 100. Do some cross products. Again, 15 times 680. Don't get afraid of the big numbers. And then I'm going to divide by 100. 15 times 680 divided by 100 gives me 102. And here's 72% of 5,000. Of 5,000. That's my whole. So 5,000 is going to be down here. 72%, the percent always hangs out with 100, so it's going to be up there. So I'm going to get 100x equals 72 times 5,000. Big number, 72 times 5,000, but that's okay. 72 times 5,000 is massive. It's like 360,000. We're going to divide that by 100, and I'm going to get x equals 3,600. Don't worry if your numbers seem big. You can always go back and plug them in and check. All right, so that's one example. Another classic example is in a similar figure situation. Okay, proportions can be used to solve problems with what we call indirect measurement. In fact, people use indirect measurement all the time. Construction workers, landscapers, all the time, because there's often things we have to measure the height of and we can't do it directly. You can't climb up a flagpole to measure the height of a flagpole. You have to figure out another way to see how tall it is. Well, here's the classic example. We use cross products and set up proportions with similar figures. And hopefully you remember similar figures from geometry. But let's take a look at this problem here. Jake is 6 feet tall, casts a shadow 15 feet long. At the same time, there's a tree that casts a shadow 50 feet long. How tall is the tree? All right. Very helpful to draw a diagram and label the situation. So here's Jake. And over here I got a tree. Look at that nice tree. All right. Now you're going to draw stuff, and I know it's not going to be nearly as dynamic and lifelike as what I'm drawing. That's okay. Just get something down on that paper so you can see where the relationships are. Here we have 6 is to 15 as h is to 50. So we're going to compare Jake's height to Jake's shadow equals the tree's height to the tree's shadow. 6 is to 15 as h is to 30. They do some cross products, divide, they get h equals 20. So that tree is 20 feet tall. Now there's another way we could do this. We could compare shadow to shadow. So I could do Jake's shadow to the tree's shadow equals Jake's height to the tree's height. So I could say, all right, 15 is to 50 as 6 is to h. When I do my cross products, I'm going to get 15h equals 300. And if you notice, that's the same as what we got over there. The key here is you want to have the same proportion either in the same fraction, so comparing Jake to Jake, tree to tree, or you want the same measurement. So shadow, shadow, height, height. And if you notice, as we look across, Jake is my numerator, and Jake is the numerator, the tree is the denominator. Now maybe I'm making this a little more complicated than it has to be, but basically there's more than one way that you can set this proportion up and still get the correct answer. If we look at the example here, we've got a school building. It's 40 feet tall, casts a shadow 104 feet long. At the same time, there's a flagpole, and it casts a shadow 169 feet long. So here we have a flag, and it's up on a flagpole, and then here is the school. There's some windows, there's a door. Again, they don't have to be, very lifelike. We're not going for Bob Ross here. It's okay. Maybe it's a little too lifelike. Here, we'll just do this. The school is 40 feet tall, and its shadow is 104 feet long. I don't know how tall the flagpole is, but I know its shadow is 169 feet long. So here's my proportion. Height to shadow, height to shadow. It's going to be 40 over 104 equals h over 169. So that's 104h equals 40 times 169. 40 times 169 is 6760. 6,760. We're going to divide that by 104, and we get h is 65. So the flagpole is 65 feet tall. There's our flagpole. Yay, it's a flag. And it's 65 feet tall. That's it. And that's proportions. Your homework assignments posted in Schoology. Work on it. Hopefully you learned something today. If not, let me know. If you think my videos are super awesome and you want to see more of them, you let me know too. And I will see you in the next one. Good luck. Remember, I don't know, I was going to have some great words of wisdom. Just do your math.